Hello everyone from the Novedge team. Welcome to today's webinar. Take your designs further with new Creo extensions. PTC Creo lets you customize your product design toolkit the way you need. During this webinar, you will learn about the value each of the following extensions can unlock for your business. Interactive surface design extension, piping and cabling extension, simulation extension, additive manufacturing extension. Each extension can tremendously enhance your products, your team, and your business digitally. Today's webinar presenter, Andrew Leedy, is an associate pre-sales technical specialist and works as a member of the Virtual Center of Excellence to answer technical questions, identify potential software solution, and communicate software capabilities. And let me tell you a little bit about Novedge now. Novedge is one of the largest online stores for design software. We offer a huge assortment of software solutions that cater to virtually every designer's needs. As you can see, this is the PTC Creo product page, and we have a special promotion now. If you buy one, you can get another license half off. It's a great deal. Come check us out at novedge.com. And for more daily software news and other promotions for all sorts of design software, pay a visit to the Novedge blog and follow us on Facebook, Google+, or Twitter. Coming up next week, making the most of 3D PDFs with Bluebeam Review. And last but not least, today's webinar is free and it's being recorded live. So if you want to rewatch this or any webinar episode in our collection, just head on over to Novedge's YouTube or Vimeo channels. And now I will pass the microphone and the screen to Andrew.
Okay, thank you for that introduction. Can you see my screen real fast before we start?
Yes, Andrew, take it away.
Okay, perfect. Thank you for that introduction. My name is Andrew Leedy. I'm here with PTC. I'm an application engineer here. I work out of Greensburg, Pennsylvania, and I'm going to be taking us through 4 different Creo extensions today, talking about the value and what you can achieve with these different extensions. To start off, we're going to be talking about Interactive Surface Design Extension, or ISDX. That is our as extension inside Creo specifically for surfacing. Before I talk about the solution at all, I really like to just take a step back and talk about some of the challenges that we're hearing from our customers that you might be running into as well when it comes to dealing with surfacing or needing an extension like this. And the main thing about it is that surfacing is hard, as simple as that is. It's easy to extrude and revolve things, but more complex surfaces and features can be pretty difficult to manage at times. Also, concept design a lot of the time happens outside engineering. There can be a disconnect here. How do I go from a concept model to my actual parametric model, defining all the different parameters and things that are going to define that product? Sometimes concept design might happen outside of Creo. So there are very good tools out there for concept design, but when I go to an engineer, he may have to start all over or redesign this within Creo or within another CAD engine to get the finalized manufacturable product. And all of this matters because cosmetics do matter. We worry about this because I want my product to look good and I want it to sell. And that's where the ISDX extension comes into play. It is an extension inside of Creo specifically for surfaces, and in particular, more complex surfaces than we can achieve with just normal base Creo or base CAD. Now, a little bit about the capabilities. It is a very intuitive and flexible surfacing tool. So it's easy use, and there are a lot of things that we're going to be able to do with it. It combines free-form and technical surfacing in a single environment. And I want to be able to do both of these, because that's important. I might just want to put a curve in that's just going to sit there and it just move around however I want, but I also want to be able to define these curves with very specific end conditions and parameters. And it really allows users to develop compelling design variations very quickly. I just want to see what works best and make those changes very fast, try out new things, get new ideas out there. We can design precise curves and surfaces to achieve highly engineered manufacturable products. So it's not just good enough that I design something in CAD, it looks really good, it looks like I can build it, but then I go to manufacture it and I find out that there was a problem with something I did. Maybe I have a surface, I can't thicken it, I get an error, I can't solidify it, I get another error, whatever it is. We need to make sure that our surfaces are actually usable. And I want to be able to confidently explore design variations, and I want to be able to leverage off direct curve and surface editing abilities Just play with different things. Set certain areas to be designed parametrically. Set others to be freeform. See what works best and be able to do that extremely quickly. And just create better products that look better, sell better, and get to market faster. Now, who would an extension like this be for? One is concept and industrial engineers, anyone who is doing the early concept work for our products. But it's also for engineers and designers, people who are running Creo or another CAD that just need a good cosmetic shape or a shape that is very specific to a particular use case, and they want to have control over that. Now, just to introduce this, I really like to just show a quick demonstration on what ISDX looks like before we move on to our next extension. So here we are within Creo. We're going to be working with this shaver here. So we have a few of the basics laid out for the key pieces, and I want to work on a shelf for this. Now, a lot of times, our concept design starts with just an image. So in this case, we can bring an image into Creo, just a JPEG, and we want to put that in, give us a foundation to build off of, something that I can decide where the curves are going to go and how they're going to work all together. Now, this is just a 2D image, so we might want one for the top two, since we're going to be working on a surface that's going to encompass this entire razor in all 3 dimensions. And with Creo, I can very easily bring those in and position them. So now we're going to go into ISDX and start worrying about our curves, worrying about our surfaces. So we find that right there up in the ribbon. I can go through and just start adding some different curves in, some basic curves. So this is just going to give us a basic framework that we're going to be able to manipulate later. It doesn't matter that it doesn't look exactly right at this moment, because we can always go through and manipulate these curves in different ways a little bit further down the road. So for instance, at each different endpoint for all those different points that I select in my curve, I can select how they're all going to work together. It's going to be a very hard control. Do I want this edge exactly normal to this plane? Do I want this to be tangent in this area? Or I can just freely drag that to achieve the same purpose. We could also add in these curves, and as we add in these curves, just make note of our model tree over there. We actually have a style tree in addition to that. So these curves actually sit outside of our regular model tree. So it's very easy to go back in, find what curves are defining a particular surface, and start to go through and modify them a little bit. We also have the control for doing things like curvature plots. So very specifically, being able to see where the curvature, how it reacts in a certain area, and finely tune that to a certain degree, adding in another extra layer of complexity there. So it really allows us to gain absolute control over these surfaces that are going to be, or these curves that are going to drive our surfaces. Now we can do the same thing at the bottom, just add in some constraints, tweak some of those points. It doesn't have to match the sketch exactly, but it is really nice to have some concept to work with whenever we start this design. And the same thing at the bottom with the curvature plots, just to be able to see exactly what we're working with. Now to go a step further with this, I can style in an automatic 4-view look. Now this is what a lot of concept design tools have, and this is what we have within Creo with this particular extension. So a lot of the time we have our surfaces and curves being driven in more than one direction. I want to be able to look at it in ISO, a front, a left, and so forth. And this just makes it really easy to do an edit and see exactly what's changing in every single direction as I make that change. And every view is going to update whenever that change goes through. I can also lock myself to a certain perspective and just be able to move back and forth between the different looks very rapidly without even having to worry about where my camera is going to be positioned or where my screen is positioned. And we could design these curves just as we did before, just saying exactly what the endpoint conditions are, adding in some additional points, just tweaking it in all those different directions. Maybe for a final curve, we're just worrying about the end of our razor here. We can just finish that out. The 4-panel view really helps with this. I don't ever have to rotate around my model when I adjust my curves in different directions. I'll do it within one view, basically. Now, once we define our curves, I want to go through, utilize these, and build a surface. It's also important to note that at any time, I can always go back in, add some more control points by finding the style tree and tweaking it a little bit further. Now, we might just want to hide these images away. We don't really need them anymore. We have the starting points of our curves. We can build our surfaces to kind of take the place of those images that we put in. Now, adding a surface is a simple matter of selecting our bounding curves and then selecting exactly how I want my surface to interact at the edge of each of those curves. Do I want it to be tangent, normal, etc.? How smooth do I want this to be laid out? And notice again our style tree, the surfaces and curves all get placed within these away from the rest of our model tree and features. And at any point, I can just throw some additional curves to drive our surface. We can lock these curves to a certain plane very quickly and utilize that 4-panel view again to build this out. And here we also have it mirrored across another plane so that it can be built out in another direction as well, so that we have the same kind of control of the curve in all directions of our razor and really get down to the level of detail that we need. I can also duplicate my curves to add more control further back. So we're not just restricted to what we have whenever we build out the surface. We can always add in more control where it's needed, bump something out, define the surface a little bit more down the road, and do this all very quickly, make all these adjustments as fast as possible. So now we can go through. We've almost finished out here. We now have those extra surfaces in the middle that are defining the top shape. Well, let's also have them drive the bottom of our razor as well. So really making use of some of the extra work we've already done, have the same curvature, the same line drive both our top and the bottom, really getting us the smooth curve that we're going to want for a aesthetic product such as this. And always go through and adjust how exactly we're going to react at the edges of all those different surfaces as they meet up with the curves. And now we have a product that looks pretty good. If we want to go through, do some analysis of this, we can always do things such as a zebra plot, be able to see how the curved surfaces are coming together and if we're going to have any issues. At this point, if it looks good, we might be done with this. I might be all good to put this back in with the rest of my assembly because it's all Creo. It doesn't matter that this was designed using a different extension. It all will go with the rest of my parts just fine. Now I can go through, thicken this, solidify it, whatever I want to do to make this a manufacturable product. And the last thing I want to note is that if I ever make a design change, it's all Creo. My surface will update. Doesn't matter. We don't have to worry about there ever being issues. As long as I built this right with the correct references. If I say this was built off of a plane, I select the edge of that or the angle that plane's placed at, it's going to go through and do that change for me. So this is not a separate surfacing tool. Everything is connected within Creo. And that's going to be a repeating theme as I go through the rest of these extensions as well. So now, just to wrap up ISDX, what we get is an extension that is very easy to use. It's Creo. We're not going outside of Creo to do work. It's intuitive and easy to pick up. We can also go from very simple to very complex. We can just design a cone or design the entire cockpit of a helicopter. We get those precise curves and surfaces that are going to be highly engineered and, more importantly, manufacturable. That is the biggest point. We want to make sure that what I do in the virtual world is actually usable in the real world, and I can actually work with this. Overall, just be able to increase our engineering productivity and efficiency. I want my designs to be easy to make, easy to modify, especially if I have a complex part. I won't have to go back and do any redesign. What we're getting is more options and more concepts. Try new things, develop ideas further. And at the end, gaining those high quality, aesthetically pleasing products that we want. This is the goal, and we want to get this done fast. So that is the interactive surface design extension. Now, switching gears up a little bit, I'd like to go into piping and cabling a little bit. So the piping cabling extension is all about going from a seamless 2D schematic to a full 3D design of my piping and cabling laid out all within Creo. As I did with ISDX, I just want to tackle some of the challenges that we're hearing from our customers around piping and cabling and how it could be something that's difficult to manage within a CAD system. One of those challenges is that routing is done on the shop floor. It could be a huge mess, disorganized. There might not be a real clear plan in place. The workers might know where the things are going to, or the cables are supposed to come from or go to, but might not know what's supposed to happen in between. Third-party tools can help with this, but another issue is that they might not be integrated. You set everything up in one system, then print it out, and then you might have to design in the other one with the CAD, and then you have to try to figure it out on the shop floor at the end. And we just are dealing with incomplete and inaccurate documentation. I don't want to have to find out that I have a problem when the guy is climbing into the fuselage and finds it for me. So that's where the piping and cabling extension is going to come into play here. So some basic capabilities of this are that it is an integrated suite of tools for complete routed system design all within Creo. And we get three different parts of this. One is 2D schematics. Lay out the process in a 2D environment, top level approach, very simple to read, very simple to go through and maintain. Then we can bring that to the 3D world with a 3D cable design. Go to the 3D world with my 2D information and have my model and have my assembly driven by that 2D information. So if there's ever a change, I can go back and have that propagate all the way to my CAD model without too much manual effort by me, the engineer. We also have 3D piping design with this. So just as we did with cable design, let's have the 2D environment add some intelligence into our 3D piping design. So how does this start? Well, we're going to start in the 2D world with the 2D schematics. So it's a single multidiscipline UI. It could be bought as either its own software, Creo schematics, or it can be integrated in with Creo. Regardless, we have something to go really deal with any kind of issue with that. And this allows us to lay out the process and all the major components and attachments we're going to need. We can add in blocks, circuit, wiring, piping instrumentation diagrams, set all this up in that simple 2D world. And when we're done, spit it out as an XML import, get it into our CAD, or share it off with the rest of our team. Then we could take this into the 3D world, going into our cabling design first. We have the capabilities to route manually or automatically route that from the schematic. Do whatever is best for my current system. We can also create some cable and specific parts, markers, splices, tie wrap, shrink wrap, add in the extra detail that we need within our models. Then at the end, create my bundles and ribbon cables, and that will allow me to have a very good visual representation as well as having a controlled BOM. Then going into the 3D piping world, going from the same type of design, we can go from the 2D schematics into our 3D piping to automatically route or manually route. So a lot easier using the schematics if we want to have some extra intelligence taken into Creo before I even have to start any work. We can also deal with lightweight representations of these pipes. It tends to get pretty messy, so it's nice to have something like this in, especially if we're working with a large assembly. We want to cut down on the load times. Like in this instance, we have a factory floor or a part of a warehouse, so we have a bunch of piping going through. It's a very large area. The simple representation cuts down the load time of that. And we have extensive manipulation tools to customize these pipes further. Dealing with our pipe shape, bend radius, stock, anything that I need to customize with these, I have the ability to within Creo. We also have fittings per specifications. So whole library of fittings spec'd out to all kinds of various sizes, put those directly in Creo very easily. And we have rule compliance. Have the system do a sanity check for me. What's the minimum and maximum radius that I'm going to be able to manufacture? Is there a missing fitting anywhere? Is there going to be a flow violation? So really take the brunt of that work off of me, have the system go through, run a check for me, see if everything's okay, and then tell me that. And then at the end, this generates some automatic cut lists, bend tables, BOMs, and drawings, and everything can be taken out from there. So let's take a look at that as well as what we did with ISDX, just to get a deeper dive of this. So the PTC Creo Piping and Cable Extension is really going to allow us to create routed systems quickly and easily. These systems are going to be designed directly in a 3D environment, or they can be designed or driven by a 2D schematic. So in this example, we're going to be dealing with the design and for the wiring and piping of this rocket assembly. So we have a particular subassembly where a lot of that work is done. Let's go through, start with the 2D schematics, take it to the 3D wiring and 3D piping. So we're going to start in that 2D world with Creo schematics to review wiring routes and add in our connections. This allows us to avoid errors and ensure a good top-level approach. It's a lot more cleaner environment rather than the 3D world. It gets a little more complicated. So we can just add in new wires, select them from a library of standards to create new connections. It's going to be a dedicated environment, all with the goal of improving design and documentation and ensuring my design integrity. And it's also a 2D environment. And at the end, we're going to be able to support the exporting of our wiring and piping diagrams in standard formats such as XML if we want to get it over to Creo Parametric. This can also integrate completely with Windchill. So if we're on Windchill, have this be published straight to there, and then have that drive our 3D assembly, all with minimal manual effort to get that information over into Creo Parametric. Now in the 3D world, we have our 2D schematics set up. That's going to be driving some of the intelligence here. So we can open that subassembly for our cabling within Creo Parametric, and that new wire that we added in is ready to be routed. Now, as soon as I go to route some of those wires within my cable and extension, PCX can automatically find if there's going to be any errors. So as soon as I go through, I see, well, we have a missing connector that I need to go through and do a little bit of a manual fix. A lot of this might be done automatically by having the same kind of names thrown out. And if you have the same name for two things in the two different worlds, it's going to recognize that those are the pieces that are connecting up and might do a lot of this work for me automatically. But in this case, We did not do that. I need to fix that connection there. Now, as soon as I select off where that component is supposed to be, it's going to trigger me that I'm all good and I'm ready to route that cable. Now, we have a lot of different routing options. All I have to do is select on what cable I want and then say how I want it to get where it's supposed to be going. Just a simple route, the fastest way I can get there. Via network, do I want to follow a cable or a pipe? A lot of different ways on how to manage that. So in this case, we're following a network. I might have a start of a cable or just a line that I've built out. Just have that cable automatically be placed in for me that way. We can also follow another cable. So I have 3 more other cables. I want them to follow one that we've already placed in or one that we've just placed in and automatically have those be routed in that manner as well. Now for our last one, we might want to put those in, but we could see that we might have an interference. And it's really easy to fix interferences. All you say is, I wanted to avoid this particular part, and it's going to find its way around that. So very easy to go through, take your 2D information into the 3D world, have it drive that design intent. Now, creating our manufacturing information from this is very quick and easy. We have a 3D cabling loom that can be automatically flattened, and individual components can be easily displayed here. The harness can also be outputted as a drawing, including a bill of materials, really significantly shortening the product development cycle for us. And the best part is all this is associative, so any changes to my 3D design are going to be automatically reflected in my 2D drawing. Now in the piping world, that is very similar to what we did with cabling. So if we get out of here, we go back into Creo, the piping is going to be very similar. It's a dedicated UI, but this time for our piping design. And routing piping is quick and easy. If I have an interference with my pipe, adjustments can really be made on the fly to apply quick changes with draggers or exact offsets off a point. We also have lots of ways to add in new pipes. So it's very simple to select a starting point, reference an existing pipe or a point that we want to go through, and have it route in that manner. Now, as with cabling, any changes are reflected in my manufacturing drawings. And what we get with the drawings is a piping assembly. We can have our bill of materials generated. We can also have individual pipe drawings automatically generated for me as well, with all that extra information that we put in the system. What's my bend radius is supposed to be? Have it do all that work without as much automatically as I can. If I have to do something manually, I can do that as well. So with the extension, engineers can quickly and easily create our routing systems and the designs using either a 3D modeling approach from the start or have it driven by a 2D schematics approach. Now, just to recap on what we saw with piping and cabling, we get a lot of value out of this. So piping and cabling can be an integral part of our detailed design process. So it's something that's not done separately. It's just part of my design. And we have a lot of different electronic verification and rule checking added into the system to have it go through, do that sanity check for me, do that extra check before we even get down to the shop floor to find out that we have a problem. And at the end, automatically create associative manufacturing deliverables. Let's not do things from scratch. Allow the system to take that load for me again. Overall, be able to reduce our time to market. So spend less time constructing things on the shop floor and less time designing. Reduce that development cost. Do this right in the first time in a very complete manner and have it go through. If there's ever a change, have it all update for me. And overall, just lower our lifecycle costs. Faster design, faster build, and have a better record of all the work that was done. So that is piping and cabling extension within Creo, a very quick look at that. So now moving on, shifting gears again, we're going to be talking about Creo Simulate. So Creo Simulate gives engineers and designers the power to analyze and understand structural and thermal product performance early in my design process with seamless integration with the rest of my Creo suite. As I did with the other extensions, just taking a step back, talking about some of the challenges that we're hearing, and one of those being that analysis is seen as something that the experts do. I'm an engineer, I design the part, someone else is going to analyze it, and this is where most of our problems stem from. I'm limited in my design by how long it takes for this communication to occur and how well that communication occurs. Maybe I might be talking with them and sending off the same product multiple different times. Analysis is also seen as something done to catch problems and not to make the best design. Am I making a smart design decision when I do something with my design limits in mind? Or am I waiting to the end seeing, wow, we have a big problem. I need to go back and fix all the work that I just built out. And that's because analysis is done late in the design design process too. If we catch a problem late, it's going to be really expensive to fix that problem, especially if it has to deal with a complete redesign of a product or a part of our product, and just adds on to our lifecycle costs, quality and performance of the product, and the product development costs as well. So Creo Simulate was added into Creo to alleviate some of these problems, give engineers the power to do a quick simulation within their design environment without ever having to step out of the Creo suite. It can do structural and thermal analysis to understand our product performance and to optimize digital designs. It's also an integral part of the Creo Parametric Suite. So it's not a third-party product or different interface that we have to learn. It can be very quickly accessed, and it can be even accessed directly from within Creo Parametric itself. And it really just enables designers to make better decisions earlier. I want to design a better product, not just one that meets my pass-fail tests that I had set for it. I want to have the best product that I can possibly build and work with my design limits in mind throughout the whole process to achieve this goal. We're able to conduct optimization and feasibility studies to improve my initial designs. Is it better to do this or is it better to do that? And this can be done very early on and throughout the design, because we don't just want an answer, we want the right answer. We want the best possible design that we can push out. We have a lot of different options of capabilities that we can choose from in regards to what studies we can run. And whatever you're working with, we probably have a solution here. If we don't have something here that you're currently doing that might fall into our advanced simulation, which goes a little bit beyond the scope of this, that's for more specialized or not as common simulations. We're not going to touch too much on that today. Now, in terms of how the product works, well, we have automatic and advanced meshing controls, and the user can always have manual overrides to this. But a lot of this can be just done by the system so that you can get back to design the product. Just do a quick simulation. Don't have to worry about how my mesh is going to be set up. I don't have to do all that if I don't want to. I can just go through and just say, just run a simulation. What does it look like if I put a load at this point and I have it held down here? We can conduct optimization and feasibility studies to improve my initial design. So what happens if I change the thickness, or let's just change the height? It really just answers those what if scenarios. If I can do it fast, let's just try it out. Let's improve the product as we build it. And let's build it with that in mind, with how can I make this better as I'm building it? And just parametrically vary my properties in my simulation model. So since it's within the Creo suite, we can just easily toggle back and forth, make those changes, do a study. Something's not working, go back, make another change, see if it worked better this time. In terms of results, after we're all done running a simulation, we have the automatic results using templates. So easily toggle between looking at stress, different types of stresses, von Mises, principal stresses, displacement, strains. And then we can output all this information, Excel, an HTML report. So easily document and share across our entire enterprise. We also have the ability to query result values directly on the model using simple mouse clicks. What is the stress at this particular point right here? I see that this could be a problem. What is that value? And view fringe, isoplot, vector plot, graphical results, just various different ways to view the results to gain the best outlook that I need. So let's take a look at what simulation is all about and how this would look within Creo. So we're going to start the simulation demo with this machine press. So this press is held up by some frames on the outside, and on these frames we have these orange lifting lugs that allow us to put this in place. I want to make sure that these lugs are going to hold under my new loads in this design. So we can go into this on the part level just to see what we're currently working with. It's a very simple product, a very simple piece of metal, but I want to go through and do a simulation to verify that this is going to work. So applications, going to simulate, allowing us to have a seamless integration with PTC Creo. And here's where I would set up everything necessary for my simulation work. I can choose what mode we're going to be in, what loads are going to be applied, my material selection, try out different materials if I want very quickly. Maybe to start this off, we want to set up our constraints. At the top and the bottom, we're going to have this welded down to the edge of the frame. I can go through, customize that a little bit more if I wanted to. In terms of the forces, I just have some simple forces I want to apply. They're going to go in the holes where my attachments are going to go. I can set up and control how my load is going to be distributed. Is this going to be at a point? Is this going to be over a certain area? However I want to apply that. And then I can just give myself an expected value just to see what we could be working with here. And I could just very easily go back through and adjust these or try different loads out if I want. And we could always preview. Creo is going to tell us exactly what that load is going to do to it, or what load's being applied. So if I want to go through and adjust this before I even run my test, this isn't what I'm looking for, maybe I can do that with that preview. So now we have a test set up, or we have some constraints set up. I want to go through and set up my test. So we have a lot of different types of studies we can do. Maybe we just want to do a standard static study just to get this started. So it's going to prompt me to say what kind of constraints I'm working with, what loads I'm doing. So I could set up multiple of those and just have multiple studies running through all of them if I want, however I want to manage that. Now we can choose what convergence method we want to use. So do I just want to use a simplified, a single pass, automatic meshing, or do I want a multi-pass and then be able to adjust the values a little bit more? And then once I have that all set up, this is going to be standard study, I can just run that straight from within this little window here. And I can always pull up this menu to see what the test is currently working on, verify that it's making progress, and it's going to tell me when the run has been complete. Then it's a simple matter of just viewing my results. And we get all these results just published to us automatically using a template that I'd set up. We get animation for the displacement. We have multiple things we can plot: displacement, stress, strain, all kinds of different categories within those subcategories. And I can look at these results and say, well, maybe my stress is too much at one of those points there. I need to do a design change. So how would I manage that? Well, we can do something called a sensitivity study. So a sensitivity study is going to allow me to run one of my previous analyses that I've already done, and I'm going to say to the system, well, when you do it, change something. So we can say, well, from the variables within my model, we might have one that's in particular. I saw that the stress was very large around this fillet here. Let's change that. Let's work with that and change it over a certain range to see if there's a better value for that I didn't see before. Then I can go through, run that new study based off of the old one that we ran. So rerun the test. And then we can go through, we might want to control how we're actually going to display in a little more control here instead of using a template. I could say, well, how exactly do I want to view these results? What values am I going to be reading? What's going to be plotted to and against? And then go through and actually plot that graph out. So we can view the results and just see how the stress reacts to that particular radius of that inner fillet. And I can see maybe my design, I really want it to be around 11,000 for that von Mises stress, and that occurs at 0.4 for my variable. Now from here, I could just go through and change this value, or let's take it another step further. Let's have the system do this for me. And we do this with something called an optimization study. So that takes us even further. And the optimization, we have a lot of different variables within this model. In addition to that fillet, maybe if I change something else, it will improve my model even more. So let's go through, let's do an optimization test. Let's have a goal in mind. Maybe I just want to minimize my total mass. I'm worried about the cost of this particular little bracket here. If I can cut down on the mass, it'll cut down the cost of it. And then I want to go through and say, I'm really concerned with the maximum stress. And I have that value that I pulled from that sensitivity study. All these are building off each other. And I have a good limit in mind of what's looking good, where this all plateaued off at. And I might also be concerned with my maximum displacement. That's another value that was floating around in my head, and I know that it can't go past a certain amount for my particular design. Then, keeping those design limits in mind, I want to go through and change all kinds of different variables. I want to change that inner fillet that we just did to change over a certain range. But I also want to be concerned about a lot of other variables within my model. I could just pick one, I could pick two, I can pick all of them. So right here, we're just going to go through, change our angle. Worry about where those bolts are going to be placed, how far out from the center they're going to be, how long is that left piece going to be, how tall is it going to be. So just going through, picking on some different measurements that I think that we can improve upon, and just have this system, hey, change everything for me, run through. I just want this basic shape in mind, but run through and give me a completely different optimized shape. And I'm going to go through and say specifically what range I'm concerned with. This thing can't be too tall, it can't be too wide, but we have a lot of flexibility in between maybe. So just going through, selecting what the minimums and what the maximums are going to be, and then just having the system run that analysis for me and spit me out a completely optimized shape. What's important to note is that it's all Creo also. So if I ever want to just pop back in my design, make another change within Creo, and then come back in here and rerun any of these tests or rerun an optimization, that's entirely possible. Now this time, the results might take a little bit longer here, but as it's going through the different iterations, it's displaying exactly what those values are being changed to. So we can see how it's changing it, the general method about how it's going about optimizing this. So this could even give me better intent and better, in my head, a way to design this better down the road. Just seeing what the system has seen that reduces the stress for this particular shape. Then it's going to complete and we can view the results in much the same way that we viewed a lot of those other results before. Doing an optimization like this could take me hours if I want to do this manually, but just let the system take the load, spit me out that answer, and give me that new shape with the maximum stress now at 11,000. We can also go through and we can view our optimization history. So I can see what Simulate did on each step to reach the goal. Now this isn't particularly too useful if I just want that final shape, but it does give me insight into what was changing. I mean, right away, it tried to change that fillet to be much bigger. So down the road, I might know, well, that fillet needs to be much larger than what I originally had it at. So Creo Simulate really just lets us work on a part and not only get a pass-fail test, but a completely optimized goal part to reach my final design goals. Now, just to wrap up Creo Simulate as well, what we get is just lower product costs overall. Discover my design flaws early to increase my first time build success. I don't want to have to redesign late in the design phase. Reduce or eliminate the need for my physical prototypes. The testing can just be done within Creo. I don't have to worry about pushing this off into another program. Let's just do it all from, just jump from my design into the simulation right away, run the test, and then come back with that knowledge and really leverage all of that to reduce my material costs. So we can make sure that the design we put out is the best possible version of that. Overall, just be able to lower our lifecycle costs. Reject designs before those costly prototypes are produced. Find our faults early by simulating often. Simulate early, simulate often. Overall, just be able to decrease the costs associated with those long product development and review cycles by cutting down on that, and also reduce the aftermarket service and warranty expenses. If a product is faulty, I really definitely want to not find that out after we ship it to our customer. I talked a little bit about the packaging for this, and I'm not going to go into very much detail at all here, but just for your information, the simulation extension covers a lot, but doesn't cover everything. It goes into the advanced simulation for that. So that's for those more specialized or not as common simulations there. So that's really Creo Simulate. Now, to wrap up this demonstration, we're going to take a look at our final extension here for the day, and that's going to be the additive manufacturing. So taking a step back, 3D printing is a huge revolution in the world of manufacturing. You're able to make custom production parts built in very difficult geometries that were seen as impossible to manufacture before additive manufacturing came along. Robust CAD models are the start of this process because good CAD design leads to our good prints, but many times existing CAD systems do not address the challenges of this new technology. And that's because CAD and additive manufacturing are kind of seen as different domains. You do your setup, you build your model in one program, then you have to send it off to a splicer to figure out how the G code is going to be built or how you're going to design the G code to go to your 3D printer, and they're just two different systems there. You also cannot create additive manufacturing specific CAD features very easily. So a lot of the time you might need lattice and support structures built into your model, but many CAD systems do not support the ability to do that. There's also no printability checks in CAD. As we talked about before, you really don't want to design something that looks perfect in the 3D world only to find out that this isn't manufacturable, and that's the same for additive manufacturing. You want to be able to see, is my product actually able to be produced in this particular manner, in this particular process? And many different software packages can be used, one for lattice design, one to check the printability, one to actually send it over to my 3D printer. So at that point, you're jumping between a lot of different programs, at least usually one program to get to the end goal of having your product 3D printed. So our solution is additive manufacturing within Creo 4.0. Now, basic capabilities are that PTC has partnered with key 3D printing manufacturers, Stratasys and 3D Systems, and more coming down the road, with the goal to streamline our 3D printing workflows within PTC Creo and also integrate those 3D printers. Now, traditionally, we have a process that basically looks like this. We have our 3D model, Then we go to our optimization technology, so our topology optimization or lattice creation to reduce our weight. Then we go to our simulate software, 3D print check software, then we build it. And then we need a second iteration. We rebuild the geometry, re-optimized, re-simulate, redo the print validation, and then build it again. So the result is that we just have multiple disconnected models, and we had to leverage off many different types of software to get there. And if there's ever a design change, well, we got to repeat the entire process again. So here at PTC, we see this being a little bit simpler. Design, optimize, validate, and 3D print check without ever having to leave Creo and have it all be associative if there ever is a change. What's new within Creo 4, and some of that support was in Creo 3, but what's new in Creo 4 is the ability to create lattices. So I can very easily go through and just say, let's put a lattice inside of my product. I want to reduce my weight of this and have it do that automatically for me, while still having complete control over how this lattice is generated. We have the ability to maybe do a lattice without a shell, lattice with a shell. This is just going to be another example, but this is the case, we just replace the entire structure with a lattice. So a lot of different ways on how we can place those in. Maybe we want a more simplified lattice. In that case, it was a more complex 3D. In this case, we just have a 2D representation of that lattice. So really whatever complexity we need to do to add in that lattice. And what we get is an initial weight of 4.9 can be turned into 3.8 by just putting in a simple lattice. And this might not even be an optimized version of that lattice. And going further than this, we can use Creo Simulate to even optimize this a little bit further, optimize the individual cells that are going to be placed within my lattice. And PTC, as I had said, is partnering with Stratasys with that goal of streamlining my 3D printing workflows, and support for additional printers is going to be planned. But basically what we get is the ability to print straight from within Creo to those select printers. So never even having to go out to generate G-code outside of Creo. So let's go through, take a look at what this extension is all about. So here we're going to be working with this robot assembly, and we have these 3D printed grippers at the end that are going to go on our robot. They're going to be used to pick things up. Now, I want to minimize the mass of this because I'm going to be 3D printing it. I'm worried about my material cost. If I can cut down on that, that's going to be great. Might even cut down on the time to print this. So what we're going to do first, blow out the inside here so that I can add in a lattice. And now we have something I can work with. Now, the lattices are found over in engineering, lattice, and all we have to do to place those in is select our bounding surfaces, select what type of lattices we want to put in, what extra configurations we want to put on those lattices, and then just have it generate automatically. In this case, we're bounding it in between that cleared out area, as well as having the front and the back of the bracket of that 3D printed part be where it's telling me to stop building lattice. So we can automatically generate that in, change the size around if I want, explore different lattice types. Maybe we don't run a really complex 3D. I just want to have a regular 2D approach, much more simplified, could cut down on my print time, or I want to go through and maybe make this quasi-radial. I'm looking for a little bit different. I want to add drain holes. Basically everything related to our lattice design we can do within Creo now. Now going back to our 3D lattice, maybe this is what we want to end up with. We're just going to have a regular lattice. I want to remove dangling beams so that we don't have anything that's really being useless within there, and have it generate that for me. So now we have this nice generated lattice within Creo. We could see exactly what this looks like. And I could always go through and change all the different parameters associated with that, the different angles that those are going to go off at, the size of that inner area. And we could see just from putting in a lattice, we've reduced our mass a lot. Now what we're concerned about is, well, this robot needs to be able to pick something up. So how do I know that this lattice is actually going to still hold up to the loads I'm going to put on it? And that's where we can really just leverage our simulate software. Now we already did a lot of simulate already, so I don't want to go too far into it. We've already placed some loads and constraints on here. I just want to go through and do a quick study of this to see that we are still able to hold up structure with this and that this thing isn't going to break. That could be a major concern with me. So now I can go through, have that study set up. I just want to run it. It's going to give me a verification when it's completed, and then we can go through and display some of those results. What we get from this is a result that looks much like what we did before. We have an animation playing what it looks like, whatever it's deforming, as well as being able to display those different stresses and strains and displacement and everything that I'm going to be concerned with. And I might say, well, this cannot go over a maximum displacement of a certain value. So let's query that result, put that on my test so I can share that off, and let's go through and optimize that a little bit to make sure that that is lowered, but we still are able to hold up, reduce the mass. So going through, doing another optimization study, the only reason we're doing this again is I just want to show that this lattice feature can be completely optimized. Just as we do any other Creo parametrically designed part, we can do the same with our lattice. So it's all sitting within the same world now. It's all Creo, seamless integration with all the other different applications. We don't have to worry about it being in a separate domain. Our lattice doesn't have to be something that's only done by the 3D printing prepare guys. Now we can start picking on some of those different lattice variables that are going to drive our optimization. You could say exactly how large that can be, what's the minimum that we want it at, and then go through and run our study. And I can choose as many of those different variables as I want. I can even optimize the entire lattice shape if I want to go that far. Now I've already gone through and done this optimization. This might take a little bit to run, but we can just go through and plug in the results that we would have got out of that. Now go to our lattice anytime, just with any other Creo feature, we can always go back in, edit it, change those values around, try different things. In this case, we're going to put in some of the different ball diameter and cross-section size that we got out of our optimized shape. So go through, customize this a little bit further, and we actually get a preview on the right as we go through and change anything that's going to verify that that's what we want to be done. And now we have a fully optimized 3D print lattice within our Creo part. Now going a step further from this, I want to actually manufacture this. So how would I manage that? Well, we can go through and do a 3D print check within the actual Creo software. If we ever want to go back into our analysis, rerun all those different tests to verify that this is actually going to hold up before we do that 3D print check, we can always manage that as well. Analysis is going to take a lot less time to run than an full optimization study would do. But you're going to see we get a lot of the same results that we would have gotten beforehand anyway. So we can pull up those results and we can in fact see and measure out that maximum displacement. We have lowered that. It was over -2 before. Now we've lowered it, into the 1 to 2 range. So making improvements as I go through and do my design. And really 3D printing is all about going through and making sure that we are prototyping. It's basically prototyping. So I want to make sure that when I build my prototype and I take 4 hours to do this 3D print, that I'm not going to have to do another 4-hour job to prototype this out. I want to put this right on my robot and see that it works and not run into that problem. Now, in terms of actually getting that over to our 3D printer, remember we said that we can hook up to select printers. And even if I'm not printing directly to a printer, I can still set some of these values up to do a validation check for me. So say for my particular printer, what's my minimum wall thickness, the allowed gaps that we can do, the tolerances on all of that, and I can go and manage my 3D printers. So we can very clearly say, if I have different printers I'm printing to, have it set up to go to either one of those. And then let's go set up our tray. So we can prepare all this for 3D printing within Creo. This is going to bring up my tray, and I can place it on there wherever I would like it to go. I could pattern this out, position this wherever I would like, print it off in different orientations, whatever is going to be best for this product. The opposition is going to try to figure that out for me. Now going through and doing that printability validation, let's validate some of those minimum parameters that I've set for this product, and let's make sure that we don't violate any of those rules. And we said, well, maybe we violate a thin wall value. I need to go through and do a change before I try to 3D print this off, because I'm just going to get junk out of this. Now going through, if let's just pretend I went through, changed some of those values around to make this actual 3D printed for the particular printer that I had set up. We might want to have more than one of these on a tray. I might want more than one different part on the tray. I can assemble those in just as I would assemble in any other Creo part. And then once we have more than one part, let's check our global interference and make sure that these aren't run into each other. If I want these to be for 4 different robots, I want to make sure that they're not connected up whenever the 3D print's all done, or I need to find some way to separate it. Then once that's all set up, let's view how this will actually print out. So based on the type of printer I have, we can display the support material for that, how it's going to build, and also go through and worry about how this is going to build out. It's going to build layer by layer, most likely. So let's go through and actually click through this, see if there's going to be any issues. Then if we have a select printer, print straight to there from within Creo. Otherwise, I can just go through, do a save as, get that off as an STL, as I'm used to doing beforehand. But otherwise, that's additive manufacturing within Creo. And just to wrap up the entire presentation here with that additive manufacturing section, we're getting fast time to print, doing more prototypes in less time, and having those prototypes actually be more worthwhile. We're not finding problems that we could have done in a simulation or I could have done in a 3D print validation. We're actually testing out to see if it's actually going to work in its current capacity. Ensure those first time printing successes. We don't ever want to have to fail those. And reduce software maintenance of having to jump between all those different pieces of equipment or pieces of software to get this to its final printable stage. Make full use of the printer capabilities. The printer is able to print very complex shapes. Let's make use of lattices because that's going to reduce our overall mass, but it might be impossible to do that with some other manufacturing methods, but that's not the case with additive manufacturing. Build out complex custom parts and get those parts to be production parts, have them work. And that's additive manufacturing with PTC Creo, and that is all the other 4 extensions within Creo as well. Now, I believe we have some time at the end here if anyone has any questions on anything that I presented today.
So first of all, thank you, Andrew, for such a thorough overview of this extension. I don't think we have any questions, but we'll leave it open for a few minutes if anybody can come up with anything, or if I'm sure they've been thoroughly satisfied about this display. But I wanted to mention something. These extensions are great, and you can choose among them. You know, we have them on our product page on our website at novedge.com. But actually, you know, there's a promotion going on right now where if you trade in your existing Creo license and subscribe to Creo Parametric Essentials package, you can choose 3 out of 4 of these extensions, and they come with your package at no cost. So pretty good, huh? So you don't have to choose after all. I mean, you leave one out, but you know, it's a pretty interesting deal. In the meantime, no, Andrew, I don't see any questions. So I guess I will take, let me take the screen back, and I'm gonna wrap it up saying a couple of things. Thanks for attending, everybody. And I want to remind everybody to visit our page at novedge.com, where you can find PTC Creo and extensions. And our next webinar this Wednesday will teach you how to make the most of 3D PDFs with Bluebeam Review. And if you want to rewatch today's webinar or previous ones, I urge you to check out our Novedge YouTube and Vimeo channels. We have webinar for every software taste. And I want to thank again Andrew for spending the past hour with us and being such a great presenter. I really enjoyed all the 4 extensions on display, and I hope everybody else did too. Have a great day, everybody. Thanks again, Andrew, and looking forward to another webinar.
Have a good day.
Bye-bye.